The interactive problem D was my favorite in this qualification round of Google Codejam, but before I show you my performance from the contest with commentary, I will explain to you the statement and we will solve together some easier interactive version of this problem so you'd see how to start with an interactive problem. The statement says there is a hidden sequence, you don't know it, with exactly 100 elements, each element is 0 or 1, and you can call function query of I to know the ith element. The value of it will be given 0 or 1, you need to find the whole sequence and print it at the end. But after every 10th query, so after query number 10, 20, 30, the sequence might be changed and it's random. With probability 50% it's reversed like a string, and with probability 50% every element is changed from 0 to 1 or the other way around. Maybe both those events will happen with 25% probability or none of them, also with 25% probability. You are allowed to use at most 150 queries in total in order to know the whole sequence and print it, the current state of the sequence. If the sequence wasn't modified at all, then this is how the code would look like. Iterate over indices from 0 to b-1 and say answer of I is query of I. You can call a function, it will give you a value. That's not interesting at all. Also, some detail about implementation in Google Codejam. Actually, you should read from input and print to output, so the function doesn't exist. It's not that there is function query. Instead, you can write one yourself, int query that gets integer I. You print I, flash the output. More details, technical details on the Codejam website if you want to read about that. Then you read the response, the value, and return that. From this moment, once you have this function, you can use query and now this will work and compile, you can submit that. But there are modifications. So what about just one type of modification? After every 10th query with probability 50%, the sequence is modified by flipping every bit from 0 to 1, from 1 to 0. Then we iterate through the array again. We count the number of queries already asked, and if that count is divisible by 10, this is that line, then we ask about, for example, the very first element again, query of 0, and we check if it's different from what we remember as answer of 0, this is that if, then we iterate through the whole prefix already visited, and we flip those bits, because we know their states changed. For example, let's say after 4 queries, the sequence gets flipped. If we know that the prefix was 1011, and after 4 queries maybe all of that was flipped, then instead of asking for the 5th element, I ask about the very first one again. If I get answer 0, then I know indeed the sequence was flipped. So this is the current state, and flipping is achieved exactly here. Also, we need to remember to add 1 to the number of queries, because to compare this 0th element with the actual state, we need a query. And this in total, how many queries will be used? Around b times, I think, 1.1, something like that. Because we need one query for each element, but also once every 10 queries, we ask additional one. So something like 110, 111, 12, but we are okay, the upper limit is 150. And the full statement now is that there can be 2 modifications. Every element might be flipped, and or the whole sequence is reversed. And then the whole plan doesn't work, because after some prefix, and now sequence is possibly changed, we ask about 0th element, we get to know that it's 0 or it's 1, but this is not enough. Maybe this came from the end of the sequence, because the sequence was reversed. You can now think of a full solution while watching me thinking about the solution and implementing it, or just jump to the end of the video to get the summary. Enjoy. Correct, cool, I'm very happy. Problem D. An interactive problem that will be hard to implement for sure. So something happens with the array a lot, but okay, I can get information about first and last bit. How many queries? 150, b is up to 100. Problem D. Test cases. There is T and B initially. Let B be global. I don't think we print case this time. I need to carefully follow input line by line. Number of queries up to this. There will be some array. What do I want to do? I will ask about those. A of L is query of L. A of R is, that's ugly, query of R. Do this. Actually repeat this a lot of times. Print I with a flash and read the response. Answer of this size. One, two, 3, 4, 5, 6, 7, 8. After 9, 10, I'm rolled again. Here I need to ask about some extra things. Do I? Like 2 last bits. Is the array random? No, it isn't. Two-thirds of my queries should be good. What happens is the flip. One, 0. If every opposite pair is 1, 0 or 0, 1, then I don't distinguish between flipping and reversing. And asking about 1 bit is enough. If there is some pair equal to each other, then I can just ask about those two guys. Let's try to find a pair equal to each other. Answer of I is equal answer of b plus 1 minus I. This then found is I. Actually, I could keep that, but whatever. The complexity doesn't matter. The number of queries does. Found is minus 1. Then it's enough for me to ask about one thing. new value is right. Query of 1, if new value is different than current this, then flip everything. From R. Else do nothing, but else if found is not -1, ask about that, and what do I understand? I need to ask about both. And for simplicity, let's say that I ask twice, so that always I would make 2 queries in this case. And 8 queries will be used. That's good enough. Else first, say 1, query of found, query of b+1 minus found. Those are two the same. Or one of them is enough? Wait. I was looking for 2 equal. If I found 2 equal, oh, then that's not enough. I need to ask about one of them. If one is not answer of found, then there is a flip of states. I don't like copy pasting, but it's the pressure of time. You don't always implement nice things in contests. But also, I need to ask about somebody who is different. Found diff is -1, then I don't need to worry about anything, just query something again to make up 2 queries. Else, if query of found diff is different from answer of found diff, then the reverse happens. In both cases, this. If L is greater than R, is B even? I hope so. Yes, it is. Then we print. How to print the answer? I should read the response. A is answer, I believe. Nope. I want the tool. Check. I also need testing tool. What you're seeing right now is me trying to download and run local testing tools, because it isn't easy to run locally an interactive program, because after anything there should be a query and you theoretically can write from keyboard an answer like 0, 1, but it would take an hour to simulate the whole process. Instead you run something that runs against your program and communicates with it. Oh, here it is. This is testing tool. And now I can run. Program is D. What? I didn't create the runner? Okay. That's bad. But this is why there is qualification round. Is that good or not? Let's try something bad. Answer of 1 is XOR equal 1. This should make the answer bad. Well, it worked. But what about tests? Where are tests? Not here. I believe it tests enough. Also, this means that I wasted a lot of time. I should have checked the leaderboard. I'm going to wait because it's just too dangerous. I should have checked the leaderboard to know if I can risk it or not, because I'm going for the first place. But I think I'm good. Nobody solved it yet. Runtime error on a big test. That's bad. That costs time. What, too many queries? Do I increase the number of queries by 2? Yes. What happened is I tested everything locally, it worked, then submitted and got wrong answer or runtime error, whatever. Something is wrong. And only then I realized that they give you some command to use, but by default there's some argument there. By default it's 0 and it only runs for the first test where b is equal to 10. I locally tested only for b equal to 10 instead of b equal to 100. Should I give an argument? Oh no, this is argument. I wasted a submission. Okay, I have a bug. And I could predict that. Because of course first test checks nothing. Okay, let's check the logic. That hurts. I should have read the manual. I'm looking for equal and a different. I believe it should be this. I'm now looking at L and B. Well, shit. I'm guessing at this moment that this costs me a win. I will still wait. What time did I lose? 4 minutes? I think it's 4 minutes when you submit something wrong. Okay, it lasts too long. I should be good. Also, it's the middle of the night for Europe. Oh, it's hidden. Nice. Middle of the night for Europe. So not everybody participates. It's easy. What? So it took me around 11 minutes to implement with one small mistake, and then a few extra minutes to struggle with those interactive tools. But it's very important to waste that time during a qualification round, not during like round 2 or 3 when the time really matters. And then I want to be effective with those tools and have Python already installed on my machine. Now to the summary of my solution for this problem. Let's say I already asked about something from prefix and suffix. I will want to compare like maybe first with last bit to know something about what changed. After 10 queries, now I need to ask some questions to know if the sequence is still the same. Well, one way would be to go again through all those bits and all those bits, but it isn't required. What about me just asking about the first bit and maybe the last one was as well? What if the first one is 1 or maybe let's say 0? This changed to 0. I don't know if the sequence was reversed because it would also give me 0, or maybe it was flipped. Every element was flipped. What if I ask this? If this gives me 1, then still I don't know. I cannot distinguish. But if I also ask about those, this pair of zeros, and I get information that this changed to 0 and this one changed to 0, then I know the sequence was reversed. This is a reverse of what I had here a moment ago. Similarly, if I got that this is 1 and this is 1, then this would mean that the sequence is flipped. Every bit changed into its opposite. Is it enough to just ask about first 2 values and last 2 values? And what number of queries would it give? Because once every 10, I waste 4 queries to make sure. In total, it would be like 6 queries would be really effective. And I would need around, each turn is 10 queries times 100 by 6. Something like that would be the number of queries I need. 1000 by 6, I believe it's 167. So even if this works, it's too much because I have only 150 queries. But maybe some of those are unnecessary, like about this one. Though it isn't even true that first 2 bits and last 2 bits are enough. Because in this case, first pair, first last, and second last, they behave the same way, because they are opposite to each other. If a pair of bits, if they are different, they were different from, let's say, the beginning, then after every operation they will still be different, and every modification. So both reversing and flipping, it would change a pair 1, 0 into 0, 1. The same for this pair. What I'm interested in is one pair of opposite bits, and then maybe somewhere in the middle, some other pair of equal bits. This is some other pair, because for this, I know that if this changes to 0, it means the sequence was flipped, otherwise it wasn't. My solution then is find a single pair, let's say that I will call this same, a pair of same bits, and the other one is pair of different bits, if both pairs exist already in my prefix plus suffix. Then I ask only about those and I use this information. This is just a series of ifs and cases. I can iterate over that prefix and suffix already well known, try to find a pair of same values, then I ask a first single query about this value and I check if it changed to 0. If yes, I flip all the bits I already know because I know the sequence was flipped. If not, if this is 1, then I don't. What remains is to independently check if the sequence was reversed. A pair of same values are not affected by that at all. So if all pairs so far are same, then nothing would change and I don't even need to check if the sequence was reversed. But if there is at least one pair of two different bits, a pair of different bits, then I ask about one of them, I check if it changed, after you already flipped the state of bits according to the information if everything was flipped. Now, I check if this one was changed to 0, if yes, then reverse the sequence. There is also a case where I don't find this pair of same bits in the first place, and this is what code on the right does. If found is still -1, that was I think the first position with two equal bits, then I check the very first element in the sequence, its new value is this. I ask the query second time for my convenience, because much later I do number of queries plus equal to. So I ask 2 queries to know if there was any differences, if there were differences, and then 8 real queries to know new values. But if I see that something changed here, then every bit up to L and from R to the end, I change its state by 1. Then we had that case that now I cannot distinguish between flipping and reversing, but it's really the same. I could, I think, here as well reverse, if I'm not mistaken now. What about the number of queries? Every turn of 10 queries, 8 of them will be to find new values. So we need around 100/8 repetitions of that, each with 10 queries. And this is around 125, so easily fits in the limit of 150. That's it. You can see the implementation in my GitHub repository, link in the description. And well, problem D was the last one for which I got the full score in this qualification round. Tomorrow you'll get a video for some solutions for problem E, even though I didn't solve it during the contest, but well, now I know how to do it. So see you then. Bye bye.